All right, read your joke of the day. It's a pretty bad one. Okay, I'm going to treat this just like we would if we were coming back from the break, which essentially we are. And we're going to go into some naming, which should be all review, but you probably haven't looked at it in a while. So we'll do that first, and then we'll talk about the rest of this. All right, so I want you to pause and try to name all of these. Pause and try to name all of them. And, okay, now let's name them. We'll start up here with the blue one. Okay, this is the simplest one. Remember how this goes. I always start with my longest chain. And my long chain on this one is 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Looks like 4 is my long chain. Okay, so since I can number in any particular way, it doesn't really matter because it's kind of the same thing. If I flip this around, it would kind of look the same. Then I'm going to start on the left. So I'm going to number this 1, 2, 3, 4. So in this case, I've got 4 for my long, so that's bute. Remember your numbers. Meth is 1, eth is 2, prop is 3, bute is 4, pent is 5, hex is 6, hept is 7, oct is 8, non is 9, dec is 10. So we only have single bonds here, single bonds. So this is going to be an ane. Just as a reminder, this is a homologous series called an alkane. This is part of the alkane homologous series. And its equation would be C to the N, H to the 2N plus 2. So that is also in your reference book, your reference table. So let's name this. I've got 2 substituent groups, here and here. And substituent groups, remember, are those groups that bond off of the main group. So each of them has 1 carbon, and then 1 carbon substituent group is called a methyl group, because there's only 1. So I've got 2 and 3. So I'm going to name this 2, 3. And since I've got 2 of them, I have to use the prefix di. So this is 2,3 dimethyl. And what's my long chain? 4. And that makes that butane. 2,3 dimethyl butane. Hopefully you got that one. Not too bad. How about the one on the right? The one on the right. In this case, I've got a double bond. And remember that the numbering of the carbons is determined by where the double bond or the triple bond is. If it's only single bonds, then that's going to be determined by my lowest combination, really, of what the substituents are. Okay, so this one is only 4 carbons long, and the double bond is in the middle. So since it's in the middle, I'm going to start from left to right. I'm going to number 1, 2, 3, 4. Now I could start over here, 1, 2. It's on the second carbon going that way. I could start it from here, 1, 2. Second carbon has the double bond. In this case, I'm going to go from left to right because bromine is lower alphabetically than chlorine. So I'm going to use both of those rules. So B comes before C. So what do we have here? B comes before C, so when I'm naming it, I'm going to put 1 bromo, 4 chloro. Now also remember that when we have double or triple bonds, we have to name where the double or triple bond is. So that's 1 bromo, 4 chloro, and then 2, my long chain is 4, is bute. It's a double bond that makes it an ene. 1 bromo, 4 chloro, 2 butene. Now remember, these can get weird too. This could be 1 bromo, 4 chloro, bute, 2 ene. You might see it either way. Okay? All right. Let's try this one. This is a cyclic. We call it an aromatic hydrocarbon. We do have a couple of substituent groups, a couple of halogens here. So this is a halogen substituent group. So what do we have here? How many? First of all, 1, 2, 3, 4, 5, 6. All right, so I've got 6. This is a cyclohexane. I don't have any double bonds anywhere. Then I would have to number my carbons according to where the double bonds are. In this case, I don't have any double bonds. So I'm going to name this and start my numbering of the carbons according to these two substituent groups. I've got a bromine and a fluorine. Which comes first? B comes before F. So, next thing I have to think is, which way do I go? Clockwise or counterclockwise? Well, I want the lowest combination of numbers. So if I start here, I could go 1, 2, 3, 4, 5. That would be a 1 to 5. If I start here and go clockwise, I could be 1, 2, 3, 1, 3. So I'm going to choose the 1, 3 since it's a lower combination of numbers. So here I am, 1, 2, 3, 4, 5, and 6. So, hopefully you got 1 bromo, 3 fluoro, 'cyclohexane. 1 bromo, 3 fluoro, cyclo, I've got to put cyclo in there, that tells me that it is a cyclical hydrocarbon, an aromatic, and then the hexane tells me how many carbons are in the ring. Okay, 1 bromo, 3 fluoro, cyclohexane. All right, how about this last one here? Let's switch colors, let's make it black. All right, where's my long chain? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. 6 seems to be my long. Any double or triple bonds? Yes, there are. 1 is right there. That determines, or that is used to determine where I start my numbering for the carbons. So, do I start here? 1, 2, 3, 4, 5, 6. Or do I start here? 1, 2. So if I start from the right, that means carbon number 2 has the triple bond. If I start down here, 1, 2, 3, 4, 4, 1, 2, 3, 4, the triple bond would be at 4. So I want to choose the one with the lowest number. So I've got 2. So this is going to be a 2, and my long chain is 6. So this is going to be a hexine. It's going to be 2-hexine. Are there any substituent groups? Well, I'm starting here, right? 1, 2, 3, 4. Here's a substituent group. Now be careful. Some people would choose 1, 2, 3, 4 and call this an ethyl group. You got to be careful of that. Always look for your longest chain. So since this is my longest chain, this is my substituent group. So 1, 2, 3, 4, and this is a single group here. And what is it? It's a methyl group. So for methyl, and now I have to name my triple bond. So that's at carbon number 2, 2, and what's my long? 1, 2, 3, 4, 5, 6, 2 hex ine. Remember the variation? It could be 4 methyl hex 2 ine. Okay? Hopefully you got those. That's really the extent of it. You're not going to get anything more complicated than that, except maybe a double bond on this. All right? Okay. Draw these. Actually, this can't come up, so I'm going to have to try to fit it in here. Let's try to do that again. All right. I've said it before multiple times. I think these are easier because it tells you what the base is. So pentyne. I need 5 of them, yes? 1, 2, 3, 4, 5. Now it tells me 1 is where my triple bond has to be. Shoof, shoof. And then 4 is where this substituent group is, which happens to be bromo. So 1, 2, 3, 4. Here's my bromine. 4 bromo, 1 pentyne. Am I done? No. Why? I have to have 4 bonds around each carbon. 1, 2, 3, 4 around this one. This one only has 2. This one has 1, 2, 3. Need another one. This one only has 1, so I have to have 3. 4 bromo, 1 pentyne. Okay. Last one. What the heck is that thing? 1 chloro, 4 fluoro, 2,4-dimethyl, 2-pentene. All right. Well, again, I need 5 carbons. 1, 2, 3, 4, 5. This 2 here tells me that it is, the double bond is at the ene. I know it's a double bond because it's ene. Remember, triple bonds are ine, and single bonds up there are anes. Okay? Just as a reminder, if it's a pentyne, if it's any kind of ine, that's C to the N, H to the 2N, minus 2. Pentenes are C to the N, H to the 2N. Okay. So, 2-pentene. Here's 1, here's 2. So I'm going to put a double bond here. That's a double bond. I'm going to have to erase this because it's a mess. 5 carbons. 1, 2, 3, 4, 5. Number 2, I'm going to put a double bond. Good. 2,4-dimethyl. So here's carbon number 2. Here's a methyl group. 1, 2, 3, 4. Here's another methyl group. So that part's taken care of. 4 fluoro. 1, 2, 3, 4. Here's a fluorine. And 1 chloro. Here's my chlorine. All right, am I done? Nope. And hopefully you've seen the mistake I've made. This carbon right here is 1, 2, 3, 4, 5 carbons. Excuse me, hydrogens. 5 bonds around it. Naughty. So this has to have 4. It has 1, 2. Here's another 2. This one has 1. 1, 2, 3. 3 more. 1, 2, 3, 4 for this carbon. For this carbon, 1, 2, 3. So I need another one. And this carbon only has 1, 1, 2, 3. This carbon has 4. This carbon has 1, 1, 2, 3. Okay? So there you go. That's 1 chloro, 1, 2, 3, 4 fluoro, 1, 2, 2, 4 dimethyl, both of them are methyl, and 2 pentine, 1, 2, 3, 4, 5. The double bond, pentene, excuse me, the double bond is at the number 2 carbon. Okay, hopefully you can do those by now. You're waking back up into it. All right, let's go back. See what we have. Okay, you should be getting a packet today. The packets that I sent out are on nuclear chemistry, and that's going to be at least a week and a half off. I just didn't know when the next time that they were going to send a packet, so don't bring it in. And really, let me see, I don't think there's anything else in there. I should have included the last notes for organic, but I didn't. I'm going to post those instead. If they make another run, then I will send those home and you can fill those notes in. There's not a lot to fill in, but I'm going to post both the blanks and the filled in versions. We won't get to those yet until tomorrow. So really tonight, all I want you to do is to practice again on the type page, and I'm going to pull it up here, naming alkenes. As far as the notes go for the functional groups and the chemical reactions, organic reactions notes, they're also in your Regents Review book, pages 201 to 208. And a reminder, and I'll put this on the post on the Google Classroom, we're determining today what the grading system is going to be. For the college course, it's going to stay numeric, and that's all I know kind of right now. So make sure that you are still doing all your homework and such. And really, you'll have homework pretty much every day. I won't probably go as quickly as I have been because I don't necessarily need to, but you'll still have homework every day. Okay? All right, so what's the homework? It's this one. I believe, well, I will have it posted and I'll put it under the classwork section. It will be due by tomorrow at noon. All right, it's naming again. And there are 10 of them, and you can do all of them. They're kind of fun. Okay, so I will see you again tomorrow. Sun shining, get out there.